Okay, welcome to lesson 87 of algebraic concepts, nonlinear functions. So in these series of lessons, we're just looking at functions in general, how they operate, and parts of functions, and we'll get more specific later on in later lessons. So here's our objective, our vocabulary. So let's look at our first example. Does this table represent a linear function? And a linear function has the same change from the same rate of change. And we know the same slope of the line is always the same everywhere. So now, how do we calculate our slope? Well, what we do is look at the change in x. On a vertical table, the x is on top and the y is at the bottom. So our change in x is 1, is changing by 1 every time. And let's look at what's going on in y. It goes from 1 to 2, so that's 1. From 2 to 4, that's 2. From 4 to 8, that's 4. From 8 to 16 is 8. Then 16, then 32. So it looks like it is doubling. So here we have 1 over 1, 2 over 1, 4 over 1, 8 over 1, 16 over 1, and 32 over 1. So 1, 2, 4, 8, 16, and 32 is doubling. And that means that this is not linear. No. Okay, make a table of values for the function and then graph it. So this is where you would use, what did I give you guys? Desmos or some type of graphing calculator. Y equals x squared plus 4. So let's first make a table of values. So x squared plus 4, and then y. So at negative 2 squared is 4 plus 4 is 8. Negative 1 squared is 1 plus 4 is 3. At 0 squared, 5. 1 plus 4 is 5. 0 squared is 0 plus 4 is 4. At 1 squared is 1 plus 4 is 5. And at 2 squared is 4 plus 4 is 8. And then now let's do some type of graph. So at negative 2, we're at 8. At negative 1, we're at 5. You put a decimal point there. At 0, we're at 4. At 1, we're at 5. And at 2, we're at 8. So anytime you see an x squared, it's going to make some type of u. And that's not the greatest graph. I should have put a grid here for you. And so those were our two examples. I will meet you at the end of the video for a review. So let's look at what we have. Is it linear or nonlinear? So the change is 1 on x, and the change on y is 3. Wait, no, this is subtracting 3, subtracting 3, subtracting 3, subtracting 3, subtracting 3. So the change in y is -3. The change in x is 1. -3 over 1 is -3. It's the same everywhere, so this is linear. Let's just circle linear. That's what we have. All right, let's look at our our next problem. Okay, so what do we have here? We have 1, 1, 1, 1, 1 on x. On y, we have 5. We have 3. We have 1. We have -1, -3, and -5. So because this change is different everywhere, this is not linear, nonlinear. We do not have the same change everywhere. Does this graph represent a linear or nonlinear function? The absolute value is subjectively linear, but it is not made of a constant linear line. It is made up of 2 linear lines in opposite directions. So let me show you what I'm talking about. The graph of the absolute value function looks like a V. And let's plot these points. When x is 0, y is 1. X is 0, y is 1. When x is 1, y is 2. So this is what the graph of this function looks like. It looks like a V. This is not a linear function. A linear function is one line. They either go straight up from left to right, straight down from left to right. It's flat. A vertical line is not a function, but it can be described by an equation. This is made up of 2 lines that go in 2 different directions. So it is not continuously linear. And that's you look at it and you say, oh, well, it's a line. No, it's not one line. It's 2 lines. So the absolute value function is not linear. All right, so that concludes this lesson and my bungling explanation of the absolute value function. I'm sure you can read about it in whatever textbook that you pick up for more precise mathematical explanation. Thank you for watching this video. If you like what you saw, please subscribe, hit that notification bell, and share it out. I will catch you on the next video.